Okay, 2.1 Day 1, Power Functions. There are a lot of examples today, so maybe just write down the ones that you try on your own and you can watch the other ones. So we've talked about 6 characteristics. Questions in the book talk about 6 characteristics, and it's in behavior, increasing, decreasing, domain, range, and the intercepts. And we're going to organize this using a palette. I call it a palette. All right, for the y-intercept, we substitute an x 0 for the x. 0 to the 5th is 0, so we get 0. The x-intercept, you substitute a 0 for the y. Divide by 8, and we do the 5th root. Okay, end behavior. Let's look at what's happening in the table to find end behavior and what's happening at these x values. So we're going to have 8, negative 10 to the 5th power. So a negative to the odd power is negative, and we'll get negative 800,000. Negative 800,000. 8 times negative 1 to the 5th will be negative 8. And we fill out the table here. So then we can talk about end behavior. As we go out to the left, it's going to go to negative infinity, and out to the right it goes to positive infinity. Another 0 there. Okay, end behavior. So we can say the limit as x goes to infinity of g of x is, x goes to infinity is talking about this part, this x value, and what's the y value doing? It's going to positive infinity. We can talk about the left side of the graph. As we go to negative infinity, we're talking about x going this way, and that means the y is going to negative infinity. So we've talked about end behavior. Continuity. There's never a number that we can put in here that is undefined, so we'll say continuous on the real numbers. And let's plot some points. We know that at negative 1 we'll go to negative 8. And we know at 0, 0 is the intercept. And then we'll go up to positive 8. So we see that shape or that graph. And then we can talk about, more easily talk about domain. We see that nothing's missing. We can go way out to the right, and there's always going to be a y value. Way out to the right, there's a y value. So the domain is all real numbers. We can also say this. So you can say it like this, or you can say it like that. the range is all the y values that have a point on the graph. So we can go down to negative infinity, and there's the y value. We can go up to positive infinity, there's the y value. So the range is all real numbers also. And increasing, decreasing. We might look at that arrow and say it's decreasing because the arrow is pointing down. But to talk about increasing and decreasing, we have to read the graph from left to right. And this graph is always increasing. So it's always increasing. It's increasing on all x values, and it's never decreasing. And make sure you remember that this is an x, and that's an x. This is a y, and that's a y. And that's an x, and that's an x. So domain is talking about x values, range is talking about y values, and increasing and decreasing talks about x values. Okay, pause and you try the same thing. And today we're talking about power functions, meaning it's just going to be a monomial with some power. So far we've talked about positive integer exponents, and then we'll talk about negative integer exponents, and we'll talk about fractional exponents. Okay, y-intercept is when the x equals 0, x-intercept is when the y equals 0, divided by negative 4, do the fourth root, x equals 0. And let's check, see if these numbers help us describe the graph. So go negative 4, negative 10 to the fourth, and that gives negative 40,000. All the y values are negative. We have the y-intercept here. As we go out, the graph is going like that. And we can see end behavior in the graph, and we can see end behavior in the table. As we go to the right on the graph, as we go to the right, the y value goes to negative infinity. As we go to the left, the y value goes to negative infinity in behavior. And continuity, we don't have any missing y values, no missing points, no asymptotes, so it's continuous on all real numbers. Domain is all real numbers. Range goes from negative infinity to 0, including 0. Alright, so for the domain, we look at all the x values that have a point on the graph. For range, we look at all the y values that have a point on the graph. We can go down as far as we want, and there's a point on the graph. At -2, there's a point on the graph. At -1, there's a point on the graph. At 0, there's a point on the graph. But at 1, there's no point. So at 0, the range stops. And 0 is included, so we put a bracket around 0. All right, increasing. Maybe you'd say this is decreasing because it's pointing down, but we have to read it from left to right. So from left to right, we're increasing. So that's from -infinity to 0, increasing. And then from 0 to infinity, it's decreasing. You read it from left to right, so it's increasing and then decreasing, and we see that here. Remember, this is x, 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 x. This is a y value, and these are x values. These look really similar, so it's important to tell the difference, what you're talking about. This is an x, and that's an x. Okay, let's look at a different type. Okay, so now we have a negative exponent. Let's see how that behaves. The y is still, make the x 0, and we get y equals 0. So we see that x-intercept, make the y 0. And then remember that this means that. So we have a negative exponent, and just so that we know what it looks like, we do that. And we have to think, what number can you put here so that when you divide you get 0? -3 divided by what number equals 0? And that's one way to think of it, where there is no number here that will make this equal 0. We could also solve the equation like this, and then see that we get 0 equals -3, and that says there's no solution. And so we have, oh, and that means this is wrong. We should have had -3 over 0, and that's undefined. So 0 to the -7, we're going to put that in the denominator, and then it's undefined. And this is no solution. So we don't have x or y intercepts. And let's go to these values again. Remember that it's -3 over x to the 7th. So that's going to be -3 over -10 to the 7th. Point 0.000003. When we substitute all these, we get -3.000003. And we can see the end behavior is going to the right on the x, we're going to 0. Going to the left, we're going to 0. And also I didn't put a negative here, that should be a negative, but it won't matter. Negative, a number that's going to 0 and it's negative is still going to 0. Okay, so let's look at the graph. At -1, we'll go to 3. At 1, we'll go to -3. As we go way out to the right, it's getting closer to the x-axis, so it's going to go like this. And as we go closer to 0, it's going to go down that way. All right. If you don't know what's happening down here, you can always put a 1/2 in the table, and you'll get a lower negative number. Continuity is discontinuous at x equals 0, and that's called an infinite discontinuity. All right. Domain is everything except for 0, so we're going to go from -infinity to 0, and then from 0 to infinity. And then the range is -infinity to 0, and then 0 to infinity. Increasing. Increasing here, and it's increasing here. This is not decreasing. We read it from left to right. So it's increasing from -infinity to 0. From -infinity to 0, it's increasing. And from 0 to infinity, it's also increasing. And then decreasing is never. Okay, try this one. And remember that negative exponent should be rewritten with x in the denominator. And then you won't make the mistake of forgetting about dividing by 0. Okay, pause. Try this one. Okay, y-intercept is when the x is 0. I did it again. It should be 1 over 0 to the 6th. 1 over 0 is undefined. And 0 equals 1 over 6 x to the 6th, because the negative exponent makes you put it in the denominator. We can't divide by anything to get 0. We can also multiply both sides by this and see that we'll get 0 equals 1, and so that is no solution. In the table, we get a very small number here. We get 1/6, 1/6, and then a very small number here, 0.0000, etc., 0.0000, and then some numbers out there. The limit as x goes to -infinity, the limit as x goes to infinity. So this says go to the left. As we go to the left, the y value is going to 0. As we go to the right, the y value is going to 0. So that's the end behavior. Continuity, we'll see that in the graph. So at -1, we're going to be at 1/6. At +1, we're at 1/6. As we go out this way, we're going to 0. And as we go towards 0 here, it's going to go up. So we talk about continuity. It's discontinuous. There's infinite discontinuity at 0. And let's talk about domain. Goes from -infinity to 0. And then from 0 to infinity. The range goes from 0 to infinity. We don't have any y value, any negative y values in the range. And then we'll go to increasing, and we follow the graph from left to right. Increasing, this looks like it's increasing here, but it's decreasing because we have to go left to right. So we have increasing and decreasing. Increasing from -infinity to 0. Decreasing from 0 to infinity. Okay, next. So remember, probably just watch the first example and then just do the one that you try on your own. So here's another type. Okay, and remember that 3/4 means we have 8 the 4th root of x cubed. All right, let's make the x0 to find the y-intercept. And we get 0. Let's make the y0 to find the x-intercept. Divide by 8. And we're going to get x equals 0, 0, 0. Okay, let's try numbers that will be easy to evaluate. And I guess these aren't easy to evaluate, they're just some numbers. We'll use a calculator. So with a calculator we get 38. You plug in a 1, you get 8. And if you try to do the 4th root of -8 cubed, -8 cubed is negative, and the 4th root is imaginary. So we know that we're going to have a y-intercept at 0, x-intercept and y-intercept, and then the y value increases. So we're going to start there, and we have a point at 1, 8, and we're just going to see the graph go like that. If you want to check what's happening out here, just choose larger x values, and you can be confident that the graph is going to do that. We do see it's going up to 38 at 8. Okay, I'll just try to keep talking while they are talking. Hopefully you don't hear them. we go to the right. This means go to the right. We look to the right on the graph, and we are going to go up to infinity. We go to the left on the graph, and does not exist. There's nothing out there. The graph doesn't exist over there. Continuity, we'll just say it's continuous on its domain. So wherever it has values, it's continuous. And domain goes from 0 to infinity, including 0. The range goes from 0 to infinity, including 0. And it's increasing from 0 to infinity. The graph is increasing on the x values from 0 to infinity. We don't talk about 0 to infinity for increasing. It's 0 to infinity x values. And decreasing, never. Okay. Try that one. Pause, try that one. And remember that that's -4. It's going to be the cubed root of x to the 7th. Okay, we're going to go y equals -4, 0 to the 7/3 is just 0. And then x-intercept is when the y equals 0. And divide by -4. We'll get x equals 0. Okay, let's try the same points. And we're going to have -5, 12, -4, 4, and 5, 12. So we do have a point here. As we go -1, we'll go to 4. +1 will go to -4. So we see that happening. You'll have end behavior. Limit as x goes to infinity. Limit as x goes to -infinity. H of x. Going to the right, the graph is going down. Going to the left, the graph is going up. So we get that end behavior, and continuity is all real numbers. Domain is all real numbers. Range, all real numbers. The domain, every x value has a point on the graph. And range, every y value has a point on the graph. So the range is all real numbers. And increasing is never. We don't want to make the mistake of saying that this is increasing, because to talk about increasing and decreasing, we read it from left to right. So we start here and follow it, so it's decreasing, and it's going to be decreasing for all real numbers. Okay, last two. It's a long lesson. Last two examples. Okay, so now we have a fractional exponent, but it's negative, and we just have to consider roots and also reciprocals like we did before. So, before we begin, let's just leave the negative half, and then we're going to apply the negative. So that's going to be x to the 3/4. We applied the negative, and it made the reciprocal. Um, and then we can rewrite it as a root. So we'll have 4th root of the 3rd power. And just for evaluating, that would be easier to evaluate than that. Okay. Then we'll go. So the y-intercept is when the x is 0. So that's going to be 0 in the denominator. That's undefined. No y-intercept. And then let's look at, we'll see it's undefined for the x-intercept also, because we have 0 equals 1 over 4th root. This can be, we can divide by negative a half, and we get 0. But then we still have, there's nothing that you can put here to make this equal 0. We could also multiply both sides by this, and we'll end up with 0 equals 1, and that is no solution. So there's no x-intercept, no y-intercept. Let's look at these values, negative 16, 1, and 16. All right, here we're going to have negative 1/2, 1 over the 4th root of x cubed. When we do the 4th root of the negative, we're going to get imaginary. For 1, we're going to plug the 1 in there, and we'll have negative a half. Plug a 16 in, and we get negative 1 over 16. So at 1, we go to negative a half. At 16, we go to negative 1/16. It's undefined at the y-axis, and the graph is going to do this. The limit as x goes to infinity of f of x. As x goes to infinity, we're looking to the right. As we go to the right, the y value is going to 0. As x goes to negative infinity, does not exist. The limit does not exist because there is no graph out there. Continuity, we could just say it is continuous on its domain. And let's look at domain. The domain, the graph starts at x equals 0 and goes to infinity, but there is no value at x equals 0, so we just put a parentheses. The range goes from negative infinity to 0. All these y values have a point on the graph, but these don't, so these are not in the range, and these are. Increasing, we follow the graph. That is not saying decreasing, it's increasing because we follow it left to right. Increasing from 0 to infinity. Decreasing is never. One more. All right. Okay, pause. You try that one. This will be the last one. And let's remember that it's negative 5, 1 over x to the 2/3. So the negative exponent made it turn into the reciprocal. And then that's the same as negative 5, 1 over cubed root of x squared. Cubed root of x squared. Alright, so y equals, let's put a 0 in there. We'll have 1 over cubed root of 0 squared. Divide by 0, and it's undefined. So there's no y-intercept. There's no x-intercept either. End behavior. The limit as x goes to infinity, limit as x goes to negative infinity of h of x, This, well, we're not ready to do that yet. Let's look at the table or the graph, and then we'll be able to determine the end behavior. So let's try negative 8, negative 1, 1, and 8. This is going to be negative 5 over 4, negative 5, negative 5, negative 5 over 4. And we can go over the evaluation of those in class. Go out to the left, and it's close, getting close to 0. So at negative 8, we're getting close to 0. This is about right there. At negative 1, we're down there. And when we're on the other side, it's a reflection. And continuity. We could say it's continuous on its domain. Here we see an infinite discontinuity. And you can say continuous on its domain, or but let's review this type of discontinuity, infinite discontinuity at 0. The domain goes from negative infinity to 0, and then from 0 to infinity. The range goes from negative infinity to 0, and it's increasing. This is decreasing, this is increasing. Increasing from 0 to infinity, and then it'll be decreasing from negative infinity to 0. So remember, we don't read it as decreasing from negative infinity to negative infinity, because then you're talking about an x value to a y value. Here we're talking about decreasing from x to x, negative infinity to 0. Okay, that's it.